In this video, we are going to solve this question I have on the screen here, which says that what we should prove that for all integers n greater than or equal to 3, 2 to the power n will be greater than what n plus 4. So now let's look at how you are going to prove that this statement is true for all integers of n greater than or equal to what 3. Okay, so before we will be able to prove for this statement, we must test whether the statement is true for what the first n values. And in this case, the first n value will be equal to what 3, because the question says that what n is greater than or equal to what 3. So you can take 3 to be the first n value. So in that case, we have what 2 to the power 3 greater than what 3 plus what 4. So now let's see whether what you have on the left hand side is greater than what you have on the right hand side. So on the left hand side, you have what 2 to the power 3, which will be equal to what 8. And then on the right hand side, you will have what 3 plus 4, which will be equal to what 7. So of course, 8 is greater than what 7. So therefore, the statement is true for what n equals what 3. So from here, what you will do next is that you are going to assume that what n equals what k. Okay, and in that case, the statement will become what k being greater than or equal to what 3. Okay, where k is what is a positive integer. Then you have what 2 to the power what k being greater than what k plus what 4. So this is what we have now. So you are going to assume what this is what true. You are going to assume what this is what is true. Okay, so when this is true, okay, when this statement is true for n equals k, then it has to be true for the next value that comes after k, which will be what n will be equal to what k plus what 1. So when the statement is true for n equals k, it has to be true for what n equals what k plus 1 also. So what we have to do is that we have to prove that what this statement will be true for what n equals what k plus 1 also. So when n equals k plus 1, we now have the inequality to be 2 to the power what k plus 1 being greater than what k plus 1 plus what 4. Okay, so this is what you have now. Okay, so from here, I'm going to rewrite this as what 2 to the power k multiplying what 2 to the power 1, and this will be greater than what. Bringing these values out of the bracket will give what k plus 1 plus 4, and that will be equal to what k plus 5. So then you have what 2 to the power k multiplying what 2 to the power 1 to be greater than what k plus 5. Okay, so now let's go back to the assumption. Okay, so assumption, by assumption, okay, we know that what 2 to the power k is greater than what k plus 4. Okay, that's what by the assumption that we made here. Okay, so in that case, because of this 2 here, I'm going to multiply both sides what by 2. So I'm multiplying here also what by 2. So since you already know that what 2 to the power k is greater than k plus 4, when we multiply both sides by 2, the left hand side should still be what greater than what the right hand side. Okay, so in this case we have what 2 multiplied by 2 to the power k to be greater than what, distributing 2 to the values in the bracket will give me what 2k plus what 8. So in this case we have what 2 multiplied by 2 to the power k to be greater than what 2k plus 8, and I'm going to rewrite this value here as what 2 to the power k plus 1 should be greater than what 2k plus 8. Okay, so from the assumption, we've shown that what 2 to the power of k plus 1 is greater than what 2k plus 8. So let's use this to prove that what the statement is true for what k plus 1 also. So comparing 2k plus 8 to what k plus 5 here. Okay, when you look at this side here, you see that what we will have what 2 to the power of k plus 1. Okay, Let me write this here. So this will become what? 2 to the power of k plus 1 being what? Greater than what? K plus 5. Okay. So now when you look at this side here, okay, we already know our 2 to the power k plus 5 is greater than our 2k plus 8. And then looking at this side here also, we don't know yet. So you are yet to going to prove whether what the value on the left hand side is greater than the value what on the right hand side. So for us to do this, let's compare the values on the what on the right hand side. So for this part, with the value on the right hand side is what? K plus 5, and then here also the value on the right hand side is what? 2k plus what? 8. So comparing these two values, you see that what? We have 5 here and then we have 8 here, but what? 8 is greater than 5. Okay, and then we also have what? K, and then we have what? 2k. And so therefore 2k will be greater than what? K, since k is what? It's a positive integer. So then we will know that what? 2k plus 8 is greater than what? K plus 5. And then since 2 to the power k plus 1 is greater than what? 2k plus 8, then it will definitely be greater than what? K plus 5. So we say that what? Therefore the statement is true for all n values greater than or equal to what? 3. So this is how to prove for such induction question that involves what? Inequalities. Thank you very much for watching this video, and please don't forget to subscribe.